Hello class, and welcome to another episode of Motion Screencast Part 2. In this screencast, you're going to learn 3 kinematic equations. Remember, kinematics just means motion. So you're going to learn the equations that describe motion. Now before we begin, there are 3 main assumptions we are going to make when using these equations. The first and most important assumption to remember is that we assume acceleration is constant. That means the acceleration will stay the same value during a problem we're examining. The second assumption is that the initial time starts at 0 seconds. And the third assumption is that gravity is constant at 9.8 meters per second squared. We're going to start with the simplest derivation for our first kinematic equation. Recall that acceleration equals the change of velocity over the change of time. Now, according to our first assumption, we assume the initial time is 0. So now our acceleration equation is simplified. The last step is to solve for velocity. And there you have it, our first kinematic equation. To start with deriving our second kinematic equation, we're going to begin with the definition for average velocity, which is the change of position over the change of time. Again, recall that the initial time is 0. Then rearrange the equation to solve for x. However, we cannot stop there. Unlike acceleration, we do not assume that velocity is constant throughout an object's entire motion. So we must make a substitution with the average velocity definition of v0 plus v over 2. With the help of some algebra, we obtain the final equation of x equals x0 plus v0 t plus 1/2 at squared. The last kinematic equation is found by combining the previous equations to eliminate t. Below, you see 4 equations highlighted. I don't count equation 211d as part of the kinematic equation group, but the other 3 are the main kinematic equations you'll use to solve motion problems. You do not need to memorize nor know how to derive these equations. You do, however, need to write these equations down and have easy access to them for solving motion problems. Here are 9 recommended steps to solve problems. Number 1, read the whole problem and make sure you understand it, then read it again. Decide on the objects under study and what the time interval is. Draw a diagram and choose coordinate axis. Write down the known given quantities and then the unknown ones that you need to find. What physics applies here? Plan an approach to a solution. Which equations relate the known and unknown quantities? Are they valid in this situation? Solve algebraically for the unknown quantities and check that your result is sensible. Correct dimensions? Calculate the solution and round it to the appropriate number of significant figures. Look at the result. Is it reasonable? Does it agree with a rough estimate? And then lastly, check your units again. Now, let's do an example of an airplane's motion. The 2 pictures you see are Cessna's 172 aircrafts at my undergraduate university. The school is connected to Daytona Beach Airport for teaching students to fly, be an air traffic controller, or other aviation aeronautical studies. Alright, let's say a light airplane must reach a speed of 35 meters per second for takeoff. How long a runway is needed if the constant acceleration is 3 meters per second squared? The given is that the initial velocity is 0 because the plane starts at rest. The final velocity is 35 meters per second, and the acceleration is given at 3 meters per second squared. Now you can either solve for x or you can solve for the displacement. Either way is fine. The equation to solve this problem is given below. v squared equals v naught squared plus 2a times x minus x naught. Then rearrange the equation to solve for the displacement. Plug in the given values and calculate them, and you get 204 meters. Here's a harder example. A car slows down uniformly from a speed of 28 meters to rest in 8 seconds. How far did it travel in that time? The givens for this problem is that it has an initial velocity of 28 meters per second, and the final velocity is 0. The time is given at 8 seconds. We want to again find the displacement. Now this is a two-step problem. I'm going to give you the first equation to use. You want to use v equals v naught plus at, and then you want to solve for a, then plug in your given values to calculate what acceleration is. Now, the rest is up to you, and we'll discuss the solution during our next class session.